we have sigma of an, where an is 1 over n times square root of natural log of n. When n goes to infinity, the bottom goes to infinity, 1 over infinity 0. So we cannot use the test for divergence. Okay, the limit of an is 0, so we cannot conclude the series diverges from here. In any case, let's try to use ratio test. Then we have to find the limit of an plus 1 over an, and that limit involves a square root of natural log of n plus 1, which is very difficult to compute. Most probably the limit test fails. If we want to compare with 1 over n, okay, let's try. At least natural log of n, when n goes for 2 to infinity, for big, and square root, this will be bigger than 1. If this is bigger than 1, then bigger than 1 times n is bigger than n. So 1 over n times this one will be smaller than 1 over n. Okay, this will be smaller than 1 over n for n very large. Since 1 over n, the series with 1 over n diverges, and this one is smaller, we cannot conclude anything. Okay, if this or this n or bigger than 1 over n for large n, and since this harmonic series diverges, we could conclude this would also diverge, but not a chance, because this one is smaller than 1 over n. Okay, now let's see the way it's given. What is the derivative of natural log of x? Let's think n is x. Derivative of natural log of x is 1 over x. It's given in the way so that we can use the integral test. Okay, for that we say this is a function. Just replace n by x. 1 over x square root of natural log of x. Okay, now we want to use the integral test. For that we find the following improper integral. So here 2 to infinity, look at the given sum, 2 to infinity of fx dx. If this improper integral converges, then the series converges. If it diverges, then the series also diverges. So infinity, so we need to use limit 2 to, let's say, t, and t goes to infinity. Integral of fx, our function is 1 over x times natural log of x dx. Now we need to use u substitution, and our u is natural log of x. Okay, u is natural log of x. Then the derivative of natural log of x is 1 over x, and with respect to x, so 1 over x dx will be du, and this is 1 over square root of u. Let me do over here. Okay, then we'll have, without any limits or definite integral, we have now 1 over square root of u and 1 over x dx, that is du. Let's evaluate this. U raised to 1/2 on the bottom, take this to the top, so u raised to negative 1/2, and entire derivative of u raised to negative 1/2 is u 1/2 negative 1/2 plus 1 positive 1/2 divided by positive 1/2, and this 2 goes to the top, so 2 square root of u. By the way, this integral is, so we have limit t goes to infinity, and we need to evaluate from 2 to t. This is 2 square root of u, so 2 square root of u means natural log of x. Okay, let's evaluate at the upper limit and lower limit. we get 2 square root of natural log of t, replacing x by t, minus replacing x by 2, we get 2 square root of natural log of 2. This is a decimal number anyways. When t goes to infinity, natural log of t also goes to infinity, and the square root of infinity, very big, is still a very big. Infinity times 2 is infinity, minus this is a finite number, so this is infinity. That means this improper integral diverges. The integral diverges. Consequently, the given series also diverges. Okay, then the given series also diverges.